Today we're going to start on power series. What we did in 9.7 were polynomials, but if you made any of those infinite, it would be a power series. So we're going to today talk about power series somewhat in general, not how you generate a power series. We'll talk more about that later. But if x is a variable, then an infinite series in the form, the summation as n goes from 0 to infinity of a sub n times x to the nth power, which looks like this, where all those a sub whatevers are constants, is called a power series. This one is actually centered at 0. Here, we can center it somewhere else. The summation as n goes from 0 to infinity of a sub n times x minus c to the nth. Same sort of thing. Looks a bit like a Taylor polynomial, right? It's just that this is centered at c. So that's a power series centered at c, where c is a constant. So again, primarily the difference is simply that the polynomial is finite and the series is infinite. So a power series that's centered at c can be thought of as a function of x, where the domain of f is the set of all x for which the power series converges. So it may not converge everywhere. There are three possibilities. The most restrictive one is the series converges only at c. When we say at c, we're saying at x equals c. Because notice, if x is equal to c, every term other than the first term just drops out. That's the most restrictive. The least restrictive is the second possibility, that the series converges absolutely for all x. It converges all the time, no matter what x value you put in. The ones that are more interesting, i.e. ones that we're more likely to ask questions on, or we're more interested in, are these. There exists a real number, capital R. I really wish they hadn't used capital R. We just used it for a remainder. Can you guys get together and decide, what to do? It should have been little r. It really should have been little r, because I'll show you in just a second, such that the series converges for the absolute value of x minus c is less than r, and diverges for the absolute value of x minus c is greater than r. Why should it have been a little r? Because the number r is the radius of convergence. We've used little r for radius for years. Why not continue to do so? I'll get off my soapbox about this. So in the first case, r is equal to 0. There is no radius. It's just a single point. In the second case, r is infinite. I can go infinitely to either side of the centering. But in case 3, we have something that looks like this. Here's our centering point, and if we go r to either side of that centering point, everything inside of this will converge, and everything outside of that will diverge. Now, at c minus r and at c plus r, you have to look. It's possible that it can converge at both. It's possible that it can diverge at both. It's also possible that it converges at one but diverges at the other one. And we'll talk a little bit more about that in a few minutes. So notice, and the College Board likes to ask multiple choice questions about this sort of thing. Let's say that you had something and you knew that your series was centered at, say, 3, and they told you that at 4 your series converges. And they'll ask you all these other questions. Well, if it converges at 4, then And let's say that it also converges at 5. So if this is 5, it converges at both of these, right? Converges at 5, converges at 4. And they might ask you about, well, what's going to happen at, for example, 2.5? What has to be true at 2.5? It's got to converge. What about at 2? It's got to converge. What about at 1? The answer is we don't know. Just because it converges at 5, it could be that the radius is 2 and it converged at this endpoint but not at this endpoint. But anything within 2 of 3 to either side, it should converge. So it's going to converge for all of this in between 1 and 3 and in between 3 and 5. Okay? All right. I think that the book doesn't delve into that enough. So let's find the radius of convergence for each of these series. And the majority of the time on these, we're going to use the ratio test. Now, sometimes on the AP exam, they'll prompt you to use the ratio test. Sometimes they won't. But it's almost always using the ratio test, mostly because they almost always have factorials in them. Okay? So, if we take the limit as n goes to infinity of the absolute value, and remember, we're going to put the n plus first term over the nth term. So this will be -1 to the n plus 1 times, and this is a place where students sometimes get into trouble, they want to put 2n plus 2. But remember, what we're replacing is we're replacing the n with n plus 1. So it'll be 2n plus 3. Over, this will be 2n plus 3 factorial. Over -1 to the nth, x to the 2n plus 1 over 2n plus 1 factorial. Close the absolute value. So that'll be equal to the limit as n goes to infinity. So -1 to the n plus 1 over -1 to the nth is going to be -1. X to the 2n plus 3 over x to the 2n plus 1 will be x squared. And 2n plus 3 factorial divided by 2n plus 1 factorial will be 2n plus 3 times 2n plus 2. Note here that it doesn't matter what value x has. This denominator is going to get bigger than that as n goes to infinity. So this is going to be equal to 0. And remember, for the ratio test, what did we want the ratio to be in order for the thing to converge? It's got to be less than 1. So it's always less than 1. So this means that it doesn't matter what x is. So our radius of convergence is infinite. This is always going to converge no matter what x value you choose. All right, let's take a look at this one. Again, we'll use the ratio test. Do the limit as n goes to infinity of the absolute value of n plus 1 factorial x to the n plus 1 over n factorial times x to the nth, which will be the limit as n goes to infinity of the absolute value of n plus 1 times x. Well, that's going to go to infinity no matter what x value we use, with the exception of x is equal to 0, right? If x is equal to 0, every one of these terms is going to be 0. So here, that's greater than 1. So it's only going to converge at x is 0, so our radius of convergence is 0. It only converges at the center. And here's one that's more interesting. One where the radius of convergence is not either 0 or infinity. So you can use the root test on this. I'm going to use the ratio test just because you can use the ratio test pretty much on everything. But you could use the root test, but it ends up the same way. So we're going to have the limit as n goes to infinity of the absolute value of 3 times x minus 2 to the n plus 1 power over 3 times x minus 2 to the nth power, which will be the limit as n goes to infinity of the absolute value of x minus 2. Once we've gotten rid of all the n's, and we have here already, haven't we? This is just the absolute value of x minus 2. A decision hasn't been made yet, has it? Right? On the previous ones, it was taken out of our hands. One of them was infinity, one of them was 0, game over. But here, we want this to be less than 1. And you can think about this a couple of different ways. Some people like to actually solve that by writing two separate equations. Some people just go, all right, well, this is centered at 2. And, well, this is my radius, right? I can go to 1 to either side of 2. So either way, we get the radius is equal to 1. If you like to solve it, it would be, x minus 2 is less than 1, or x minus 2 is greater than negative 1. So this would be x is less than 3, or x is greater than 1. And if you do this correctly, those should be evenly spaced to either side of the centering point, which is 2. Actually, this particular one, we could have done without doing this. This is an example of something that's called a geometric power series. We'll talk more about them later. Right, the 3 doesn't matter. I could factor that out. And I've got something raised to the nth power. Well, remember that our rule for a geometric is that r has to be less than 1, right? Well, isn't that what we ended up with? that r was less than 1? Because this is what we're multiplying by each time. So it turns out that what we call the interval of convergence is from 1 to 3. And it won't include 1 or 3 because if x is 1 or x is 3, the absolute value of r from the geometric is equal to 1, and that's not going to converge then. All right. So more formally, the interval of convergence of a power series is a set of all values of x for which the series converges. Note that the convergence or the divergence at the end point of the interval, either c minus r or c plus r, must be tested separately. Now, if it's a geometric power series, we don't have to, but if it's anything else, we do. So let's take a look at a couple of those. Find the interval of convergence for each series. So we'll start by finding the radius of convergence. So I'll take the limit as n goes to infinity of the absolute value of x to the n plus 1 over n plus 1 over x to the nth over n, which will be the limit as n goes to infinity of the absolute value of x times n over n plus 1. So as n goes to infinity, that's just going to be the absolute value of x. And we want that to be less than 1. So my radius of convergence, as soon as you get rid of all of the n's, this is going to give you your radius of convergence. Once you just have either the absolute value of x or the absolute value of x minus something, x plus something. You got to get rid of all the other constants also, though, and I'll show you an example of that in just a second. So our radius of convergence is equal to 1. So that means we need to check and see what happens at the endpoints of the interval. So we know at this point that it converges at anywhere between x is negative 1 and x is positive 1, because we're centered at 0 with a radius of 1. But we need to check what happens at each of those endpoints. So at x is equal to 1, we've got the summation as n goes from 1 to infinity of 1 to the n over n, which is just the summation as n goes from 1 to infinity of 1 over n, which we recognize from our last unit as, this diverges. Why? What's its name?
Divergent harmonic series?
Very good. It's the divergent harmonic series. At x equals negative 1, we'll have the summation as n goes from 1 to infinity of negative 1 to the nth over n, which we also recognize. This is the convergent alternating harmonic series. So my interval of convergence includes negative 1 but excludes positive 1. All right, let's take a look at this last one. I'm just noticing that every single power there is the nth power. You want to do the nth root test? So that'll be the limit as n goes to infinity of the nth root of the absolute value of -1 to the nth x plus 1 to the nth over 2 to the nth, which will be the limit as n goes to infinity of the -1 to the nth. We take the nth root, we get -1, but we take the absolute value, it goes aloha. Here we have x plus 1, and the denominator will have 2. We want that to be less than 1. So multiplying both sides by 2, we get the limit. Excuse me. I don't have to write the limit anymore because all the n's are gone. All right. So we've got the absolute value of x plus 1 is less than 2. So at this point, this is centered where? At -1 with a radius of 2. Exactly right. So I need to check, well, what happens at the endpoints of my interval? The endpoints of my interval will be where x is -3 and where x is +1. And you'll see why that's important in just a second. So let's start with x is -3. Our series will become the summation as n goes from 0 to infinity of -1 to the nth times, that'll be -3 plus 1 is -2 to the nth over 2 to the nth. Which, well, if you think about -2 to the nth as being -1 to the nth times 2 to the nth, all right, I could cancel out the 2 to the nths, and I'll have the summation as n goes from 0 to infinity of -1 to the nth times -1 to the nth. Well, whether n is odd or even, -1 to the nth times -1 to the nth is going to be 1, right? So that's the summation as n goes from 0 to infinity of 1. Well, what do we know about that?
Divergent?
Yeah. This diverges. And if you wanted to prove it, it'd be the easiest thing to do would be by the nth term test. And at x is equal to +1, we'll have the summation as n goes from 0 to infinity of -1 to the nth times 2 to the nth over 2 to the nth, which is the summation as n goes from 0 to infinity of -1 to the nth. This also diverges by the nth term test. So my interval of convergence would exclude both endpoints. It's from -1 to 3. Okay, any questions about that? Not too bad? All right.